name is Lucas. This is Aiden. This is Oliver. This is Ryan. This is Ion, and she is Joanna. Our team name is the ML Infinity Bots, and our presentation today will be about the new LEGO Robotics 2025 to 2026 FLO LEGO Robotics Innovation Project. It is mainly about how to preserve fossils, or in other words, protect them from rain or decay, things like that. We chose this topic because we decided that archaeology was better than dinosaurs. No, it wasn't. Our teacher said that. And also, that archaeology was useful in daily life. Now I shall pass it on to Aiden, who shall make some problem statements.
Thank you, Lucas. Paleontology has a long history, but at its core it is mainly about studying fossils. Fossils are left by an organism directly or indirectly, permineralized through water and preserved through pressure. However, very, very few organisms become fossils because of the conditions required for it to be made. Paleontology helps us prove Darwinian theories of evolution, continental drift, the origins of species, and the environment they lived in. Fossils come in all different shapes and sizes and are not just limited to dinosaur bones. Other kinds include index fossils, which are fossils used to find the ages of other fossils. Because fossils in sediment are layered, like a cake, one can derive the age of a fossil in accordance with another that we already know the name of. A different kind is fossil resin, which is tree sap turned to stone. It preserves small fossils in stunning detail. If you have watched the Jurassic Park movies, you know exactly what I'm talking about. Microfossils teach us about the microbiological environment before ours and teach us about the bacteria that existed and how they lived. Lastly are pseudofossils, which are not actual fossils, but are other things. They can tell us more about what created them. Some pseudofossils include mold and cast fossils, coprolites, and tracks made by movement. I'll pass the presentation to Oliver, who will tell you about our experiments.
Hello, I am Oliver, and I'm here to tell you about our experiments. For materials, we use water, plaster of Paris powder, plastic wrap, and plastic swirls. For tools, we use measuring cups, one-time use gloves, and container. For our procedure, we first use 1 cup of water and 2 cups of plaster of Paris powder to make a mixture in a container. Next, we use the skull to represent a fossil, then wrap the layer of plastic wrap around the skull. Also, we put the plaster mixture onto the plastic wrap on the skull, then let it dry for about 10 minutes, which almost dries it completely. Finally, we repeated the process another time. After doing some experiments on plaster of Paris, we collected lots of data. For weight, we used a scale to measure the weight of plaster of Paris, and the skull with the layers of plaster of Paris on it weighed 323 grams. For absorption, we dunked a piece of hardened plaster in water to find its absorption rate, and we found about 30% of the water got absorbed. For strength, we used the Mohs scale to measure the hardness of plaster of Paris, and it got a score of 2, which is about the same hardness as gypsum. For curing time, we observed the plaster cure, and it took about 10 hours. For cost, pop cost $6 a kilogram. And now I will pass it on to Ryan.
I will tell you about our plaster of Paris with sand experiments. For doing this, we did the exact same thing Oliver just mentioned, except adding some sand into the mixture with the plaster of Paris powder and water. Our results were different though. For weight, we got 363 grams, an absorption rate of 30%, a strength of 2.5 in Mohs scale, a curing time of 20 hours, and $6 per kilogram. Now I'm going to pass the presentation to Ayash, who will tell you about the paper mache experiment.
So the way to make paper mache is to make a paste, put it on some paper, and apply it to an object. The ingredients you need are water, flour, a bowl, newspaper strips, and what we used was a scope. So first, get your bowl and make a proportion of 50% water and 50% flour, and mix it until no lumps. That will give you your paste. Then, tear newspaper strips, make sure both sides have tears. Dip both sides in the paste and keep overlapping the strips on the object until you have fully covered the scope. Then you'll need to let it cure, and once it's cured, you will be done. So, on hardness. hardness scale. Weight. Paper mache weighs 145 grams. Curing time. Paper mache took 12 hours to cure. Cost. Paper mache costs $1.98 per kilogram. And then absorption. The absorption rate of paper mache is 0.5%. Moving on to Joanna.
Thank you. After all the mixing, measuring, scratching, and trying not to handle plaster dust, we discovered that paper mache is basically the best substance for fossil protection. Strong but light. However, it takes forever to dry, so you might finish your PhD before it is ready. Pop plus sand turned out to be the middle child of materials. Stronger and faster than regular pop, but about as smooth to apply as spreading peanut butter on my fat goldfish. Spoiler alert, he might be dead. Meanwhile, pop remains the reliable grandparent. Not perfect, kinda crumbly, but always there when you need it. And cheap enough that museums still keep using it. So in short, paper mache is fancy but slow. Pop plus sand is strong but grumpy. Pop is old but gold. Until scientists invent something that is both eco-friendly and not prone to snapping in half during transport, we'll keep using pop. And finally, this presentation is done, so please give us a good applause for effort and safety goggles for the future.
Yay!